Alright, welcome back to Introduction to Python. Essentials 1, Module 3, Part 2. That was a bit of a mouthful. So today we're going to have a look at logical and bitwise operations. I hope you've got a good cup of coffee with you because that does tricks to your mind. Then we'll be going on to lists and processing of lists. So in part 1, we went through Boolean values, conditional execution, and loops. So logical operators, and or not. So an and will return true if both statements are valid. Example, x is less than 5 and less than 10. One's lower than the other, so there we go. Or is if one or the other evaluation returns true, then the result will be true. Then the inverse of the result, so not. So if the result is true, it will return false. So if x is less than 5 and less than 10, then it's going to be the reverse. So we want it not to be less than 5 and not to be less than 10. Reverse. Now, when this gets tricky is when you start compiling these together. So and, not, and or. Okay. Now, if you're watching this early in the morning, I know you haven't had enough caffeine to handle this. Just remember, when looking at a logical statement, we're trying to get a true or false result. And we're basically just evaluating multiple statements to get a true or false condition. So there's truth tables. So under the and, if the result of A and B is false, then it's false. So any combination where it's not true and true equals a return of false. And only one of them has to be true to become true. Alright, so you're evaluating two statements. Only one of them has to be true to return a true. So, not. If the result is false, therefore it's true. If it's true, then it's false. So it's the inverse of. So bitwise is where we want to compare numbers. So binary. So see the and symbol, the operator is different than the keyword. So it's the and, or, XOR, not, 0 field left, shift, right shift. So these are bit by bit evaluations. Okay, so if both bits are 1, you get a true. Or one of them has to be 1. We'll go through the examples when we get there. Now that symbol for the not is the tilde symbol, which you'll find just above the tab key on most keyboards. Okay. I know. I'm going to vary slightly from the online text because I, as I said, read it early in the morning and not enough caffeine in the system. So, when we are looking at an integer, it's stored in 32 bits. So, what we want to do is look and compare them. Now, as a binary number, leading zeros are irrelevant. Doesn't change the value. So we're going to drop them. So I is 15. So 0, 1, 1, 1, 1. J is 22. 1, 0, 1, 1, 0. Okay, remember that. So, under Bitwise and we're going to compare bit by bit between these two numbers. So line them up underneath other and apply the AND. So is the first bit the same as the first bit in the second line? No. So they're not both ones, so therefore it's a 0. Second column, both ones, ends up with a 1. Third column, both ones, ends up with a 1. Then the last two columns, not both ones, so they result in a 0 in each column. Convert that binary number back out to decimal and the result is 6. Don't believe me? Put the AND function into your code and see what you get. Simplest, easiest way, fire up, idle, and put it in. Actually, why don't we just do that here? I don't normally jump in and out of theory and prac, but why don't we just, for quick, so 15 and 22, 6. Just in case you didn't believe the maths. Alright, so, so there's the AND. So the OR. So for each bit to 1 if one of the two bits. So 15 or 22. Comparing the bits. If either one of those bits is 1, the result's going to be 1. So our result is 31. 15. Now the pipe symbol is above the enter key normally. It's almost like I did this before. So the next one is the XOR, which is the caret, which is above the shift 6. So again, the result to a 1 if one of the two bits is a 1. Equals 25. So again, we're only looking for 1. Here we have 2 1s, so therefore it doesn't match. So it's a 0. It's only when we have 1 out of the two numbers equals 1. The not inverts all the numbers. So not 22. So we have 22 laid out, and then we invert it, and we get the inverse. So where there was a 0, there's a 1. Now, quite often we will calculate numbers in 8-bit lengths. Just so you know why we do that. Because a 8-bit combination gives us 256 options or combinations from when we go from binary to decimal. So 8 binary digits will give us 256 combinations, 2 to the power of 8. And we use that a lot in programming, networking, even in normal data sets in computers. A character is a byte, which is 8 bits, and a bit is 1 binary digit. I know I'm getting a little bit off track, but just to give you the history there. So drag idle back on the screen, and again tilde space 22 negative 23, and you go, well, why do we do that? Well, we've got to store negative numbers somehow. The trouble is, there's no way to do it naturally in binary. So we have this little system. So if we turn around and work backwards, okay, we want a negative 23. So we take 23. So if we could add 1 to 22, it's 23. So we invert 23 and add 1 to it, and that gives us a number. So if we look at this number here, it is this number here. So not 22 means we're going to get a negative number. This is the binary of 22 in the invert, and then we minus 1 from that number and then invert it again, and we get negative 23. I know it's I remind you that I did warn you need caffeine for this. Didn't believe me when I said it, did you? So basically showing you how the binary is manipulated to store a negative number. So we want negative 23. We convert the decimal value into binary, invert it, and add 1. That becomes our negative value, represented by the not 22. Okay, lift shift, right shift. All right, decimal points, if you want. If we shift 22 to the left by 2 places, we're adding 2 zeros on the right side. So 00101110 is 22. Move that to the left and insert 2 zeros at the right hand side. Now I've dropped the leading zeros because they don't change the value. Convert the new number back into decimal and you get 88. And going, how does that work? 22 left shift by 2, 88. I know, it's bad. Hurts the brain. Did I have that? Font 16. Let's make it a bit bigger. Bit easier to see on the recording, hopefully. Alright, so as you can see, 22 shifted to the left by 2. Now gives us 88. Because when you add zeros to the right hand side of a binary number, you're increasing the value. Now, inversely, when we shift it to the right, we're decreasing the value. So we're removing the last 2 digits on the right hand side. So 10110, we remove the last 2 digits, becomes 101, which translates to 5. 22, gonna shift or remove the last 2 digits, gives us 5. Now, it's not too bad, is it? Alright, I know the material online is going to be confusing. I went the very simple explanation route in the PowerPoints because that is what actually occurs in the maths behind it. And that was the easiest way for me to explain what's going on. So hopefully you don't get too confused while you're reading that section. On to our lovely lists. So a list is simply a variable that has multiple values stored into it. So you got the variable name equals square brackets. So value 1, value 2, value 3, each separated by a comma. Lists can be of any data type, so they can be numbers, boolean, true, false, strings, whatever you need to store. Numbers are easy. As such, a list can be manipulated in totality or individual storage spots. So each storage location has an index. That index value is where it's stored. Now, remember, we're in binary. We count from 0. Index 0, index 1, index 2. So we're going to change 7 to 111. So the new list, after executing this line, will look like 10, 5, 111, 2, 1. We can print each value out of a list by printing the index value of the list. We can calculate how many values are stored in the list with the length function, as lists can vary over time by adding and subtracting values, changing values. So if we want to do a for statement or something like that, we need to know the length, how many values are in it. This is how we can determine it and have it so that it's accurate each time we want to run that loop. So to delete an index out of the list, we use del, del. Specify the list name and the index position, and it will remove that index. Now, that will force the recalculation of the indexes for that list. We've just removed one of the values, so we've shortened the length of the list. So if, for example, we delete index 2, we now have to create a new value for position 2. So everything that was index 3 and above shifts down 1. Just to make life interesting, instead of reading from left to right, we can read right to left. We do that by using a negative number for the index. So -1 is the last value in the index. So if you want to read from right to left, we use -1 to start the process. So to read -3, you come in 3 position values into the list from the end, starting from 1, 2, 7. So that's the third position from the right hand side. That's the result of index -3. Now, we need to be careful between functions and methods. A function is dependent on nothing. In other words, it can retrieve data, create data, or produce results from data. Whereas a method performs like a function, but it is dependent on its data set. So a method is linked to the data set, whereas the function is part of a program. So while you're looking at the individual elements, so the result of a function is what it's going to do to the data, whereas method is associated, and this is where it becomes so the data set is invoking the method to perform a calculation. So the method is associated with this data. So what are the methods that we can use? We can append. So if we want to append or insert a value, say into a list. So here you call the list name, put that dot in, and then put the method that you want to execute against that list. So append adds values to the end of the list. Insert inserts a value at a specific location within the list. Whilst inserting, you must have a pair of arguments. You need to list the positional index and the value you want. Alright. Delete works the same way. So, here we have it. We're going to create an empty list called myList. And for I in the range of 5, I'm going to append I plus 1. And then we're going to print it. So, whilst in the loop, we're filling the list. Once we finish, we exit and print the resulting values in the list. So we're adding values. So in this one, we're doing an I in the range, and because we don't know what the range of the list is, we use the length, myList, and then we're going to add the total plus or equals myList I. So each time we go through this loop, we're incrementing the index and adding that to the total. So we're basically adding all the values within the list together and then printing it out. Now, sometimes we want to just swap variable values. Normally, if you do variable 1 equals variable 2, you're not swapping, you're overriding. You're changing the value in variable 1 to the same value that was in variable 2. Sometimes you want to actually just swap them. Instead of calling variable 2, you want to call variable 1, but with the value that used to be in variable 2. So this swap process we can do by listing the variables on the left in order, and then the values we want to swap and the order that we're swapping them in. So variable 1 is going to have variable 2 result in it at the end of the function. And then variable 2 is going to have the old variable 1 result. So this is handy for swapping index locations within a list. Yes, you could do it by extracting the values in the index positions and then reinserting them in at the right index positions and deleting the other one and da-da-da. This is much simpler. So position 0 and position 4 are going to swap. So we're going to take the 10 and swap it at the end with the 5. And then the next line, we're taking position 1 and swapping it with position 3. So the total that we've done is we've reordered the list. It's a little bit easier then extracting each value and then reordering them and recreating the list. So we have a list and we want to swap them. So while swapped is true, and we said it was, we're going to swap equals false. So for I in the range, and we're going to sort it out and then start swapping. So we're going to sort it out and have it in an ordered list. But there's a lot easier method. It's the sort method. So sort puts it in the area in ascending order, and then to get it into descending order, we use the reverse method, just to make life easier than trying to do the swap. Now, let's be clear about something. A list is a memory location that contains information, whereas a variable is a container that contains a value. So var1 equals var2, you've just changed the value stored in variable 1 to the same value that was stored in variable 2. But if you do list 1 equals list 2, you are redirecting to the same memory location. You haven't overwritten anything. You've just got two ways of calling the same list. So what happens after you do that list 1, list 2 statement is if you modify anything in list 2, you also modify it automatically in list 1 because you are referring to the same list. Take a second to absorb that. Alright, so next up is the slice command. This is where we take a list and create a copy of it in part or whole. So the syntax is the list name and then two arguments in the brackets, the start index and end index. So new list equals my list from index 1 to index 3. Now, start to end -1. So we're saying 3, but 1, 2, and when we get to the count of 3, it stops. Doesn't do the last function, it just stops. So we will actually copy index position 1 and 2 into new list. Negative indices work with slice as well, but we instead of starting from the left, we start from the right. Just like when we did the value positions. Okay. We can not use the first argument. Why? Because the first argument assumes a value of 0. So we can just do the double colon end or start end. Alright, so we can only use one and it'll assume the total. I would suggest, just to keep yourself, you might, while you're starting out, actually specifying both arguments so you know what you're doing and get into the habit, and then when you got more experience and comfortable, then you can start dropping and using a default. So we can come in and look for a list to find a specific result, and in this case we're looking for an element within the list. So what we're looking for is the element in the list, or the alternative to it, if it's not in the list, so print 5 in my list. This is the list 0, 3, 12, 8, 2. So 5 is not in my list, so it's a false result. In other words, it's not in the list. 5 not in my list. Result is true because it isn't in the list. 12 in my list returns true because it is in the list. Now, hold on to your hats. An array. What's the difference between an array and a list? Well, fundamentally, they look the same. But they're not. So we're going to create an array, but they're going to be multi-dimensional. A list within a list. Alright. So, what's going on here? So, we want to create an array, and we're going to do it with a row and then append board and the row together, and it gets a little confusing, I know, but basically we're creating a list inside a list inside a list each time we go through it. So here we're basically adding a value of 3 for each I in the range of 3 into a row. Now each list is conforming to its own indexes. So in the array index, because we now have lists within lists, so what we're doing is the first one is which list in the array do we want to look at, and which element in that sublist do we want to look at. So 1, 1 means I want to look at index position 1. So this is index 0, this is index 1. And I want the second element in that first index position, which is 3. Alright, so two-dimensional list. We've got, if you like, a row and a column number. We do not limit how many we have. So a three-dimensional array requires 3 coordinates. 4-dimensional requires 4 coordinates, so on and so forth. I think that's enough. So, complete the modules labs, complete the handouts, and in summary, we hurt the brain cells looking at the logical and bitwise operations, then went through lists and how we can have lists within lists, which we call an array, just to make life interesting. Alright, thanks for joining us. Until next time, bye for now.